we have so far spoken about perimeter. So just as a little reminder, the perimeter is our distance or length around the outside of a shape. Okay, now while I'm writing this down, can you put in the chat for me what then is area? So on the chat, what is area? That's my first question that I've asked here. And just because I've seen it on the chat, remember guys, circumference is a special word that we use for the perimeter of a circle. Okay. But 3 suggestions of what area is so far. Right, so grade 8 in general, it's the amount of space that a shape takes. English. The amount of space that a shape takes up. So that's exactly what I've said over here. And if you'd seen that, you would be able to just do that. Says Kia says the area of a 2D shape is the measure of how much two-dimensional shape is covered, or two-dimensional space is covered. So guys, very basically, it's how much space does it take up. If you have this 2D shape on a surface or in the world, how much space is it taking up? That's what area is. So just to define this a little better or visually for ourselves, if we consider just a basic rectangle, okay, my rectangle is not the most beautiful thing in the world, but we're just going to roll with it. So if I consider what the perimeter, it's fighting with me already. If we consider what the perimeter of a shape is, we know that the perimeter is the length all the way along the outside of my shape, right? So that is the perimeter. The area, on the other hand, is all of the space inside the shape, or all of the space that the shape is occupying in the universe. All right. And those are 2 very important distinctions that we need to make. Very importantly as well, area is measured in units squared. Okay, so this might mean that it's in centimeters squared, millimeters squared, meters squared, etc., etc. But it's measured in units squared. Right, that's because when we do eventually go and find these formulas and work out these areas, we're going to have 2 dimensions that we times together. And because we're timesing centimeter by centimeter, we get centimeters squared, or millimeter by millimeter, we get millimeters squared. So area is the amount of space that a shape takes up, and it is measured in units squared. Okay, so once again, we're going to work with a bunch of different shapes when we look at area, and we'll chat about the formulas as we go along and we do these different shapes. Area for I don't know where I was going with that sentence. Area, we can ask quite creative and quite fun questions, but obviously as long as we've got the basics down, a slightly more complex question shouldn't be too tough. Alrighty, so let's take our screenshots of this if we want a screenshot of the definition and the visual sort of idea around this, but then we're going to have a look at an example. I'm hoping we don't have any questions yet. If you do, put them in the chat. But let's take our screenshot so we can have a look at an example, because definitions only get us so far. We actually need to look at examples. Oh. All right, guys, I'm moving. Hope we got our screenshots. Okay. So before we sort of get into this whole thing, what we're going to just do is we're going to chat about the different shapes that we need to be able to work with, how to work out the areas, and then we'll apply that as we go along. Okay, so our first shape that we need to be able to deal with is a square. Now, we know that a defining characteristic of a square is the fact that all of the side lengths are the same. So all of these sides of our square are all exactly the same length or exactly the same dimension. So when we want to work out how much space the square takes up, so Nyani had already put down the chat that the area of a rectangle is A times B, or A times B, length times breadth, but a square is a fancy rectangle. So if we ever want to work out the area of a square, essentially all we need to do is take our side and multiply it by the side. Another way to write this is to say side squared. And guys, the reason for this is, let's say for example, you had, I can't draw very well today, but let's say you had 6 blocks going down. If you say 6 blocks times 6 blocks across, in total, you will have 36 blocks covering that whole square, right? So if you carried on drawing all the blocks, you would get 36. 6 times 6 is 36. And this is where the idea of units squared comes in as we start to find our areas. Okay, so the area of the square, side times side, or if you want to say side squared, that's absolutely fine. And we'll give you a chance to screenshot all of these just now. Let's just have a look as we go along. Okay, so Sinyan has already told us how to work out the area of a rectangle. Remember, defining characteristic of a rectangle is the fact that the two opposite sides are equal to each other. So the length is equal to the length and the breadth is equal to the breadth. And exactly as Sinyan has already told us, the area of a rectangle is length times breadth. Okay, if you use cursive L and a cursive B, that's fine. But again, it's the length times the breadth to figure out the area of our rectangle. Right, our next shape is a triangle. Does anyone know how to work out the area of a triangle? Okay, so Lindor, question is, what for the square, why don't we say 90 degrees times 4? Lindor, very importantly, we are not working with angles. Area is a measurement, so we're working with the side lengths, not the angles, okay? Right, those of you answering my question of how do we work out the area of a triangle, spot on. I've got a couple different triangles here just so that we can chat about it. But the area of a triangle is exactly as you guys have said, half times the base length times, and I'm just going to be a little bit specific here, the perpendicular height. If you say half base times height, that's absolutely fine. But if we just quickly go and have a look at our triangles, what I need you to bear in mind is that any length could be considered the base, but generally speaking, we take our bottom length as our base length. So this would be our base length. This would be our base length. And in this obtuse angle triangle down at the bottom, this would be our base length. The perpendicular height is a very fancy way to just say the height from the base to the tallest point of our triangle. So for this first acute angle triangle, my height or my perpendicular height would be this dotted line over here. In my right angle triangle, it would be this height or this length over here. And remember, we could use Pythagoras in a right angle triangle. And in my obtuse angle triangle, from my base to the tallest point of my triangle, my height technically would fall outside my triangle, but it's still the height of my triangle. It's still from the base to the top or the tallest point of my triangle that I would then determine to work out the area of this triangle. We wouldn't then include this dotted space there as my base because that's not part of my triangle. We keep the base exactly as it is, and we work out the height from the base to the tallest or to the topmost point of my triangle. So guys, with triangles, like I've already just said, but I'm going to say it again, what we need to always remember is the theorem of Pythagoras. Because as you can see here, all of these heights are perpendicular or at a right angle to the base. And the second we have a right angle triangle, we could potentially be expected to use Pythagoras. So this is just one that we do need to remember Pythagoras, potentially to work out the height of our triangle or a missing side. But always just remember that whenever we have a right angle triangle, Pythagoras could be used. Saskia, I don't quite understand what you mean. Could you also use Pythag for the third triangle? In any of these triangles, we could use Pythag. So if that's what you're asking, yes, absolutely. We'd obviously have to give you information and dimensions, but in any of these triangles, we could use Pythag. Absolutely. Oops. Alrighty, guys. So area of a square, side times side, or side squared. Area of a rectangle, length times breadth. No problem. And then area of a triangle, half base times the height. And importantly, this height is the perpendicular height. Right, does anyone know how to work out the area of a circle? So Nyanya was just waiting for it. Absolutely. So area of a circle is pi times r squared. Now, grade 8, we've already spoken about some formulas that have to deal with circles. And I think Mavil mentioned this idea earlier. But remember, we have what we call the circumference of the circle. Now, circumference is the perimeter or the outside length of our circle. And this is found by saying 2 pi r, or pi times diameter. Now, what I want you guys to see is that these formulas are different. And the way I remember how to tell them apart is the fact that area is units squared, and this formula has r squared. And because it's got the r squared and we're talking about area, which is units squared, that's how I remember that pi r squared is my area formula. If I then have 2 pi r, I'm talking about the circumference. All right, so it's really important that we don't get our formulas mixed up. And we just need to remember that if it's got the r squared, we are talking about area. If there is no r squared, we're talking about the circumference. Right, so really important that we don't get them mixed up, and I put them both there for you so that you can see the difference. And it's really important, like I say, that we know when to use the circumference formula, know when to use the area formula. Okay, so I had a lot of faith in myself, so let's just do this, because I think this would be a whole lot easier for you guys to be able to see. Right, so let's take our screenshots of our formulas. Remember, this now serves as a bit of a cheat sheet for yourself. Let's take our screenshots. Alrighty. So let's put this all into practice now for ourselves. Hope we've got our screenshots. I'm moving. So let's have a look at question A here. So grade 8, my first question to you is, what type of shape is this? Just like basically, what type of shape do I have here in question A? Good. How do you know it's a square? So you're all telling me square, and I definitely agree. How do you know that it is a square? Okay, I like where we're going. I agree that all four sides are equal, but remember that could be a rhombus. So not only are all four sides equal, we also have these 90-degree angles at all of my vertices or at all of my corners. So the fact that all interior angles are 90 and the fact that all four sides are equal, we know it's a square. Okay, I'm just testing how much we remember from our quad section. So we want the area of the shape. We now know it's a square. The reason I asked you what sort of shape is it is because if we now want to be able to use a formula, we obviously need to know what shape we have. So if you guys go to the screenshot that you've just taken of your formulas, we know that the area of a square is equal to side times side, or side squared. Now we've been given what the side length is. It's 4 centimeters. So we would have 4 squared, or 4 times 4. And we would get 4 times 4, 4 squared, which is 16. Now remember grade 8, really, really important. We are looking at area. This is units squared. So we take the units that we know we have, centimeters, and this would be 16 centimeters squared. So anytime you are working out an area, your unit should always have an exponent of 2 units squared. Right, and that's basically it. Now, basically what this means is that if we take the side length, let me try to do this as well as I can, and I break it up into 4 blocks, and I take the top side length and I break it up into 4 blocks, 4 times 4, and then I fill in all of my blocks, will give me 16 squares, so 16 centimeters squared, that take up the area of my square. My blocks are atrocious. Apparently I can't draw blocks tonight, but that is essentially what an area is. It's telling us how many of these little unit square blocks fill up my shape. Okay, now you don't need to stress too much about the specifics of it, but that's essentially what area is. Okay, so I want you guys to try question B for me. And if anyone has any questions, you can raise your hand and ask me now. Otherwise, let's try question B. Go to your formulae or your formula if you need to and figure out what shape this is. And so what formula you would then need to use. Nice one. So remember, units squared. Whatever your units are, units squared. Okay, so guys, can you just ask, can we say 4 plus 4 plus 4 plus 4? So just be careful. That would be if we wanted the perimeter. So if I ask for the perimeter of the square, perimeter is talking about the outside length of my shape. And then I would definitely say 4 plus 4 plus 4 plus 4. But area is a multiplication, 4, 8, 12, 16. Area is a multiplication. So anytime I ask you for area, you should be multiplying somewhere. It happens that both answers are both 16, but one would be 16 centimeters, whereas the other is 16 centimeters squared. Okay, so really good distinction to make, Kenya. Well done for asking that question. Nice, grade 8s. Well done. Okay, so can't remember who it was, but someone right at the start gave us exactly what the area of a rectangle is. Katano, well done. Our area of a rectangle is equal to, you can say length times width or length times breadth. It really doesn't matter. I use breadth. As long as you know you've got the longer side times the shorter side, I'm good. So our length is 4.5 meters. Our breadth or width 2 meters. When you multiply them together, you get 9. Remember, it's units squared. it's in meters, so 9 meters squared. And I'm really, really, really glad to see how many of you remembered your units. Right, so Almaz, we do put the exponent on the units, and that's a really important distinction to make. So grade 8, we put the exponent on the unit. So it's meters squared. It's not 9 squared meters, it's 9 meters squared. So exactly as Almaz has put there on the chat, we put the exponent on the unit. This is for area, because area is unit squared. If it was just a perimeter question, there would be no exponent because perimeter is just units. Right, so let's take our screenshots. If anyone has any questions, now's the time to raise your hand and ask. I'm hoping I've answered all the questions that came through on the chat. I'm pretty sure I got all of them, but if not, obviously raise your hand. And then we're going to move on to another example. Good, grade 8, you're doing really nicely. Okay, so let's have a look at question C. I'm moving. So if you're taking your screenshots, you've got 5 seconds to do so. Okay. So here we've got a triangle. Now we're not going to panic. We know if we go back to our screenshots, maybe if I grabbed a pen, the area of a triangle, I'm just going to draw the triangle. I'm too lazy to draw a triangle, is half times the base length times the perpendicular height. Okay, so let's identify those sides first for ourselves. There's no point in rushing into something if we don't know what we're doing. So if we look at the base length, remember I said the base length, as the name implies, is the length at the bottom. So that's 8 centimeters. From point A to point B, I've got 8 centimeters. I then need to know where my height is. And remember, the height is, okay, your height is from your base, the tallest point of your triangle at a right angle. So I've actually been quite nice in this example. I've given you the height automatically. You didn't have to work it out with Pythagoras or anything like that. I've told you that the height is 7 centimeters. So all we do once we have what we need is we substitute. So half times the base length of 8. I'm choosing to use brackets. You guys know that I always use brackets when I substitute. You don't have to. It's completely up to you. I just like to do it. Times the height, which is 7 centimeters. Right, now guys, obviously you can just type this into your calculator, but half of 8 is 4, and 4 times 7, if you remember from the maths 24, is 28. So we get 28. We want our units squared. Remember, Amal's pointed that out for us. The units here was centimeters squared. So the amount of space that this triangle takes up is 28 centimeters squared. Hayden, please just remember it's half base times height. You've just forgotten your half there. If you then go and halve your answer, that's also absolutely fine. Okay, so guys, some people, just because I've seen Hayden's working out there, some people write this formula as base times height divided by 2. That is absolutely fine as well, because what you would get is 8 times 7, which is 56, divided by 2, which is 28 centimeters squared. So it really doesn't matter which form of the formula you use. You go with what you're comfortable with. If that is the form you were taught at school and that's what you're comfortable with, absolutely go for it. If you prefer the half and then the times base and then times the height, that's also fine. Okay, Nomkatano, I'm not sure why you feel it must be cubed, because remember I said area is a length, is a dimension times a dimension. Here's one dimension times a second dimension. So we've got a centimeter times a centimeter. And because we've got a centimeter times a centimeter, that gives us our centimeters squared. Cubed is when we start talking about volume. Okay, so cubed is when we now have 3 dimensions that we need to times and we get volume. All right, so anytime, like Simone said, that anytime we are talking about area, it is always units squared. Ivanati. Okay, so guys, I've spoken about this before, and the same applies with area. If you forget your units or you forget the squared, you will probably lose a mark. We will not deduct a mark every single time that you forget it. We would only deduct a mark once. But yes, you probably will lose a mark somewhere. Not every single time you've forgotten, but yes, you will lose a mark somewhere in one of your answers. Alrighty, guys, well done. So I just want to make sure before we move on, does anyone have any more questions before we have a look at example D? If you do, you're welcome to raise your hand if you feel you would like to. Ooh. Hey, you guys are doing so nicely. Well done. I will leave C up so that you can screenshot it as well, just in case, but let's have a look at question D. So question D, guys, is a circle, and we know that the area of our circle, if you go back to your screenshot or to your sort of formula list, the area of a circle is pi r squared. Pi times r squared. Now, in this case, I've been really nice. I've given you what the radius is. And remember, your radius is from the center of your circle to one point on your circumference. The diameter is all the way across your circle through the center. But in this case, I've been nice. I've given you the radius. So this would be pi times 5 squared. Now, grade 8, remember, on your calculator, you use the pi button. You say shift, and then it's that times 10 to the power x, because there's the pi on top. So pi, let's see if I can do this backwards. I don't think I can. Times 5 squared, and we get our answer. Now remember, your calculator will always give you your answer in pi. So your calculator gives you 25 pi. That means absolutely nothing to me. I have no idea what that means. So I push my SD button, and it gives it to me as a decimal. So this area is equal to 78, and now remember, we generally round off to 2 decimal places. I'm just going to write down a whole bunch of decimals here. And so if we round this off to 2 decimal places, this 9 makes the 3 increase. So we've got 78,54, and remember, units squared. So centimeters squared. So again, grade 8's pi button on your calculator, shift and then the times 10 to the power x button. Your calculator will generally give your answer in pi. You just push the SD button and it will convert it for you. We always round off to 2 decimal places unless the question tells us to do something specific, 2 decimal places. Alrighty, so screenshots. If anyone has any questions, please raise your hand and ask. Your calculator is different. Okay, I'm not too sure what you mean your calculator is different. Not Casio. Is it still like a scientific calculator, or is it one of the smaller calculators? I don't know what brand it is. It's gone out of my head now. Okay, if it's still scientific if it is still a scientific calculator, you should still have the pi button. It's a sharp calculator. Okay, I can do this. All right, guys, while you're taking screenshots, let me just figure this out. Sharp calculator. Okay. Yes, I know exactly which one you're talking about. Okay, it's like one like that. Am I right? Cool, now I'm on the Walton's website. We'll just pretend, right? It should have a pi button. It might just be in a different place. The pi button. I cannot find. But it should still have a pi button. So grade 8, I know I've gone off on a bit of a tangent here. Grade 8, any scientific calculator should have a pi button. If it doesn't have a pi button for whatever reason, please remember that all you do is you say pi, and for pi you substitute 3,142. So in your calculation, you would now say 3,142 times the radius squared, so times 5 squared. That's fine if you don't have a pi button anywhere, use 3,142. That's okay. Alrighty. Sorry, guys. I got very invested in the whole calculator situation. Hope we all have screenshots. Brain break time. You guys have been amazing. So well-deserved brain break. You guys know how this works. First person, I know we've had this joke before, but my jokes are becoming harder to find. I'll try to do better on Wednesday. So you know how this works? We want the first person to get this answer correct. It also helps if I know what the answer is. And when I say this answer, remember that is this bottom equation down here. I know it's a bit early for Christmas, but we're gonna roll with it. We had a Halloween theme, we've now got a Christmas theme. We're rolling with it.
Let's go, my peeps. Hi, Teacher Star.
Hello, Yolanda.
Sorry, I'm late.
No problem at all. See, the pi button. Okay. Yeah, I've now gone down a rabbit hole here. So Kenko is not a fake calculator, as far as I can see. It's not one that I've seen often. But definitely still there. This picture is horrible. You should still be able to see the pi. So Mila, I'm wearing glasses as well. Don't you stress. I don't know if it helps me improve my division though, I'm going to be honest. Okay, so we're looking for the last answer. I'm just going to zoom in a bit, especially so that you can see where there's doubles. I'm a little worried that I have made a mistake somewhere. Hey, we have definitely got the right answer. I just need to find the first person who got it. Luazi. Well done. So Luazi, if you want to raise your hand to explain it for us, that would be awesome.
Well done, Luazi.
Nice.
Afternoon, ma'am.
Hi, Luazi.
Hi, ma'am. Ma'am, the first one I said 10 plus 10, and that is equals to 30.
Good.
Yes, ma'am. And the second one I said 20 times 14 plus 14.
Good.
And that is 294. Then the third one I said 14 plus 12 times 12.
Nice.
And that is 158. And the last one I said 12 plus 10 times 7, and that's 82.
Perfect. Right, so guys, exactly 82 is our answer here. Please remember, exactly like Louise pointed out, where there's doubles and singles. So for example, in this last equation, there's only one calendar. So 2 calendars is 14, which means 1 is 7. Remember your BODMAS, you guys know all of this. And we're able to get our solution for our last equation. Nicely done, guys. Well done. All right, so let's have a look at 1 or 2 more examples because time flies. Alrighty, so I want you guys to try the first question here. So we've got a rectangle and I want the area of the rectangle. Let's give it a try. You're going to do it by yourself. Let's see what we come up with. Remember, area units squared. Hey guys, let's have a see. I'm liking what I'm seeing. Excellent. So the area of our rectangle, I'm not going to write area of a rectangle each time, area, and if you want to just say A, that's fine, is equal to length times breadth. So our length is 9,25 times our breadth, which is 4. And as you guys have perfectly said there on the chat, this is 37 centimeters squared. Please just remember your units squared. As far as I saw, most of you did remember the squared. Just remember that it needs to be units squared anytime we're talking about area. Nice, guys. Well done. Okay, so let's have a look at the second question here. Now, the second question is a little harder, so we're going to do some of it together, but we'll get to a point where you're going to do the rest by yourselves. We've got a triangle. So the first thing that we do is we write down our formula. We know it's half times the base times the height. The second thing that we do is identify those lengths for ourselves. Now, grade 8, the reason we identify these lengths for ourselves is so that we can see if we actually have that information or not. So the base length of my triangle is from Q to R. Notice how PQ is a dotted line. That's not part of my triangle. It's just there to help me with my height. So my base length is QR 11 centimeters. The height of my triangle is this length from S to P. Now we have no idea what that length from S to P is. But if you have a look, hopefully what you can see is that SPQ is a right angled triangle. So if I just take it out of the shape, there's my right angled triangle. There's SP, the length that I want, SPQ, and we know that this SQ length is 15, PQ is 9, exactly as Sinyane said there, and exactly as I was saying. the dotted length PQ is going to now help us find our height of our triangle. So we can now use Pythagoras to work out the height. And guys, in obtuse angled triangles like this is often what we expect you to do. Okay, so remember, Pythagoras says to us that the hypotenuse squared is equal to the sum of the square of your two other sides. Now, hypotenuse, remember Pythag, the hypotenuse side, remember, is the side opposite your right angle. So we actually know the hypotenuse here, it's 15 squared, is equal to 9 squared plus the SP length squared. This would give us 225, if I can do maths in my head. 225 is equal to 81 plus SP squared. I would subtract 81 on both sides, and I would get 144 is equal to SP squared. Remember, we need to square root both sides. So we get just SP, and so SP is equal to 12. And so what I've now worked out is that the height of my triangle is 12 centimeters. So now that we know that, I want you guys to work out the area for me. We said already what the area is. We wrote it down here for ourselves. So we know what formula we need to use. Let's go and work out the area. Grade 8, I am not sure what you're doing to get this area. Okay, so let's just think about this. Half times the base, which is 11, times the height, which we've just worked out as 12. If you type that onto your calculator, you get 66 centimeters squared. So let's just be careful and let's just make sure that we're doing our working out correctly, please. I have no idea where we got 120 from. I'm going to be honest. Like, zero idea. The only thing I can think of is that you didn't listen when I specifically said that we do not include the 9 in the base. The 9 is not part of the base. Okay, so exactly. Grade 8, the 9 is not part of the base. 9 is there to help us find the height. The base of my triangle is just this 11, right? That is a solid line. That's part of my triangle. The dotted line is just there so that it can help me work out what my height is. So let's be very, very careful, please. Right, so on that note, I'm going to do that in case you didn't get a screenshot of the first one. Take your screenshots here, and if anyone has any questions, now's the time to raise your hand and ask, or put it on the chat and ask. And I think we got time for one more. Says Kia, I don't know what plus means. I'm gonna be honest. Alrighty. So let's try the last one, question C. So what I want you guys to remember is what is our area for a circle. Lindo, I do see your hand. I'll get you now in a second. So remember, the area of a circle is pi times r squared. Let's give this one a try. Kagliso, the 3 dots stands for therefore. So remember, in an equation, we never ever put 2 equal signs on the same line. So we use it therefore, or the 3 little dots. Lindo, you took your hand down. I'm happy to answer your question if you still have one. Yeah, what's your question?
Hi, ma'am.
Hi.
Ma'am, I wanted to ask you for section B, why don't we calculate the 17 centimeters?
Okay, so the 17 centimeters would only be useful to us if we wanted the perimeter, because if we wanted the perimeter, then we would add up our 3 lengths. But in this case, the 17 centimeters is neither my base nor my height, and so it's actually not a measurement that's useful to me. We only actually ever use 2 of the 3 sides of our triangle. One side won't be useful to us.
Thank you.
Okay. Viso?
Hello, ma'am.
Hi.
Ma'am, for the 9 centimeters, is that, are they giving us to find us the pi tag? So in a
Yes.
test, they will give us, oh, so they're giving us a way to show how to get the 12 centimeters squared.
Exactly.
Okay.
Exactly.
Okay, thank you.
Okay, guys. Again, I'm getting some strange answers here, and I think it's because we've forgotten to work out the radius. Please remember that the area formula works with the radius. This whole length here is the diameter. So my diameter is equal to 24 millimeters. My radius is half of that. So the radius is equal to 12 millimeters. So when you go and substitute in, we've got pi times the radius, which is 12 squared. Now remember, your calculator gives you that weird pi answer, so we push the SD button, and we get that our area is 452,39 millimeters squared. Please remember that we need to have the radius in order to work out the area. You cannot use the diameter. I don't know what's happening here. Right, you have to have the radius. There is no choice. If you've been given the diameter, you first have to divide it by 2 so that you get the radius, and then you can go and do your calculation. Right, whoopsie daisies. So those of you that use 24, you are using the incorrect dimension. It has to be the radius. Okay, so guys, let's take our screenshot.